Science is fun, learning is fun. Let's have some fun, fun chem with Dr. J. Hello, science geeks! Welcome to this episode of Fun Chem with Dr. J. For today's segment, we are going to navigate one of the most fun topics in general chemistry, presenting... Wow! Kinetic molecular theory of liquids and solids. Also, we have something very special happening for this episode because we are inviting a special guest to join us for this segment. Are you ready to get into this lesson? Hop on board! The kinetic molecular theory, or KMT, helps explain the properties of solids and liquids in terms of intermolecular forces of attraction and the kinetic energy of the individual particles. Now, there are three statements that practically define the kinetic molecular theory. First, all matter is made up of tiny particles. Everything we see around us are made out of tiny particles which serve as their building blocks of their existence. And even our bodies are made up of tiny particles. Next, these particles are in constant motion. Wow, moving a lot. We're going to the gym in a marathon. Yes, these particles are in constant motion because of what we call kinetic energy. And did you know that kinetic energy is directly proportional with the temperature of a substance? We'll see about that later. Lastly, the third statement, the speed of a particle is proportional to temperature. So yes, I mentioned earlier, particles move a lot. I'm just doing Mom Daisy's favorite move, just kidding. And the speed of a particle is proportional to temperature, because the higher the temperature, the greater the speed of a particle. For instance, if we boil water, we can tell that the particles in boiling water move at a greater speed when the heat increases. So it becomes from lukewarm or cold water, then it becomes boiling water. Wow, so hot, right? So those are some real-life examples of such particle movements. Okay, I hope you didn't forget that I mentioned that we are having a special guest for today's segment, and it's no one other than the legendary Daniel Bernoulli. Now, Daniel Bernoulli is a Swiss mathematician and physicist who was recognized for the Bernoulli's principle, early kinetic theory of gases, and thermodynamics. Actually, as the host of this segment, I do have some questions for our special guest. So, Mr. Bernoulli, hello. When did you present the molecular theory?
I first introduced the kinetic molecular theory to the Europeans in 1738 through my book Hydrodynamica. Very cool of me, isn't it?
I couldn't agree more. What can you say about molecules? How do you describe molecules?
Good question, Dr. J. Molecules behave like tiny spheres in constant linear motion. With this assumption, molecules constantly collide with each other and the walls of a container, thereby exerting pressure on these walls.
Oh, I see. Thank you for such insightful information, Mr. Bernoulli. I appreciate it.
Siyempre ako to eh. Sa gandang kong ito ba naman?
Love that humor. Thank you very much. Now, aside from our very special guest, allow me to cite some special mentions of the significant names in the kinetic molecular theory. First, we have Rudolf Clausius, who was behind the discovery of the mean path. Next, you have James Clerk Maxwell, who made contributions in terms of electricity and magnetism. and Ludwig Boltzmann, the man behind the Boltzmann equation. But we're not going to discuss these three further because they're for grown-ups. And this is not a grown-ups video, so let us get into more information that we have. As for the postulates of the kinetic molecular theory, let us begin with number 1. Matter is made of particles that are constantly in motion. And this energy in motion is called kinetic energy. Oh, I've already mentioned this earlier. So, kinetic energy helps us explain the constant movement of particles in a substance. Next, the amount of kinetic energy in a substance is related to its temperature, and the relation is directly proportional. Increased temperature means greater speed. So it means the hotter a substance, the greater the speed of the movement of particles, and the higher the kinetic energy. Next, there is space between particles. The amount of space in between particles is related to the substance's state of matter. Oh my goodness, this is elementary school education, isn't it? But I'm not an elementary school teacher. We've learned in elementary school that there are spaces between particles, but these spaces vary from solids, liquids, to gases. And we are going to discuss this later in one of the next slides. Phase changes happen when the temperature of the substance changes sufficiently. So, one of the most well-known phase changes is melting. For instance, when an ice cube melts, we know that it is being exposed to heat. That's why it melted. So that means phase changes are also an indicator of temperature changes, and phase changes helps explain how exposure to heat or air or even water can change the physical or chemical characteristics of a substance. There are attractive forces in between particles called intermolecular forces. The strength of these forces increase as the particles get closer together. I may have mentioned the word intermolecular forces, but I'm not going to discuss this in this presentation because that is a whole new lesson for you guys. Okay, now I created a table for everyone to get a comprehensive review of the different properties of matter and the comparisons in molecular behavior found in liquids and solids. The properties of matter include volume and shape, density, compressibility, motion of molecules, and particles. Now, let us compare these two with each other in terms of these properties of matter listed on the right side of the presentation. Now, both liquid and solid have fixed volume. That's something they share in common with each other. However, liquid assumes the shape of the occupied part of container, while solid is a rather fixed shape and it doesn't care what the container's size or shape is. For instance, when I pour orange juice into one of my favorite mugs, a heart-shaped mug, the orange juice appears to be heart-shaped as well. However, let's say I put a Lego block in the heart-shaped mug. Does the Lego block become heart-shaped? No. So that is a real-life explanation of the volume and shape differences in liquid and solid. Next up is density. Yes, both of them, congratulations, have high density. And why? It is because the space between the particles of liquid and solid have very little space. Unlike gases contain particles that are spacious from each other. However, that is not the case with liquid and solid, thus explaining its high density. Next is compressibility. Both cannot be appreciably compressed, again because of the limited space between particles, so there is no more room to be further compressed if the substance is a liquid or a solid. In terms of motion of molecules, liquid move in a random medium speed in limited distances. Yes, limited because, again, limited space between particles. But since, hey, liquid and solid may both have limited spaces between particles, solid is a much more closely packed example. And liquid is kind of a bit more space compared to solid. This is why liquid is still able to move. However, solid, since there's no space to move, vibration takes place in one single place. Liquid particles slide past each other because, again, there is still quite some space between the particles in liquid, and in solid, the particles are merely tightly packed, and they vibrate without a fixed position. Now, since we're nearly ending our lesson for today, here is a summary of some of the concepts that we have tackled in this lesson. So, kinetic molecular theory, we can study the arrangement of particles, kinetic energy of particles, particle motion, and attractive forces between particles in solids and liquids. But since gases called me up earlier and said that they were feeling kind of excluded, I decided to include them in the presentation. Yay! So it's a win for everyone. For the viewers, additional learning for gases inclusion. Okay. So in terms of arrangement of particles, again, this is a recap of what we've learned. Solids contain particles that are closely packed and are orderly. Remember elementary school and high school when we see those cubes, illustration of particles in cubes depending on the phases of matter, solid, liquid, gas. Do you remember the cube illustration where the spheres, which represent the particles, are so closely packed? Liquids, kind of like this, and gases are like spreading from each other. That illustration, those set of illustrations rather, represent the arrangement of particles in these three. Liquids have particles that are less closely packed and are disorderly, and gases very far apart and disorderly. Trust me, my source is the Gen Chem book. Next, kinetic energy of particles in solids and liquids are low, and in gases high. Next, particle motion. In solids, again, particles vibrate in a fixed position, while in liquids, the particles slide over each other. In gases, particles move at great speeds because of the spacious distances between the particles. Next, attractive forces between particles in solids are very strong, in liquids, strong, just the middle ground, and in gases, very weak. Because this is also related with the space between the particles. In solids, it's very strong because the particles are close towards each other. In liquids, just the right amount of strong, and in gases, well, very weak. And that's all for today's episode. Thank you for watching FunChem with Dr. J. XOXO. I hope that you like this lesson and enjoyed this segment. Goodbye!